all, the topic of this video is JK flip-flop. Okay, so here in front of you, you have JK flip-flop. So if you see carefully, you'll find that this is very similar to our RS flip-flop. Okay, so this is a modified version of RS flip-flop. So just like your RS flip-flop, let us have a look at RS flip-flop, then we'll understand it more clearly. So here in front of me, I have this RS flip-flop. So we have this two NOR gates here and two AND gates, and then we have this R and S inputs. And then of course we have the CP clock plus, and here we have Q and Q prime as the output. So here also we have similar diagrams. So see, this basic body is same. We have K and J. This time K is for reset and J set. Okay, and then we have the same NOR gate. Okay, and this is how the circuit is built. Plus, in addition to RS flip-flop, we have this feedback. Look at this carefully. You'll have this line is extra. That means the Q is coming out and going in and acting as the input to this AND gate. So this AND gate has three inputs here: K, CP and Q. Okay, similarly, if you see here at the bottom, you'll find Q prime, the complement, is coming out. This is the extra feedback path that we find in JK flip-flop, and this goes in front and it acts as a input of the AND gate, lower AND gate. Okay, so here we have Q prime, J and the clock pulse. So these blue lines are extra lines that we have in JK flip-flop. And why do we have this? Because this JK flip-flop solves the problem of if you remember, invalid state or indeterminate state that we have in our RS flip-flop. Let us look at this truth table to see what the problem was. Okay, so if you remember in the truth table of RS flip-flop, when RNS is both 1 and 1. Okay, so here also 1 1 1 1. Then we had encountered this invalid in the previous RS, and then clock pulse we had the problem of indeterminate. So to overcome that, we have this new version of SR flip-flop, which is called JK flip-flop. Okay, and this addition of these lines will solve the problem of invalid state. Now let us look at the truth table. So as usual, I have the truth table here. Okay, so this is the first column is QT, Q previous. Okay, QT is Q previous. Then we have, just like RNS, we have here J, K and the new Q, QT plus 1. And then of course we have the clock pulse here. Okay, so this indicates this pulse. So as long as this clock pulse is equal to 0, okay, the output will be 0. So whenever it is 0 0, it will hold the previous state. Okay, so we will consider the truth table when the clock pulse is equal to 1. Then only it will give us the valid outputs. Okay, so that is why, irrespective of whatever is the value of J, K, QT, if clock pulse is 0, it will show the previous hold state. Previous, whatever was the previous value, it will show that without any change. Okay, so we will consider the truth table only when CK is equal to 1. So that's why this column has value 1. And then we'll start with the combination. So let us first start with the first combination where our previous output is 0. Okay. Now our truth table, if you see, I have sorted these values. Okay. If the truth table that I have in the note, the sorting is not like this. Okay. But to make it more simple, easy to understand, I have sorted it. So here what am I doing is I am taking the first combination of J and K 0 0 0 0, and I am assuming the previous value first to be 0, and with same value of J and K I am assuming it to be 1. Okay, so like that. So you'll see that sorting is a bit different. So now let us see. So if it is, the first case is when J is equal to 0, K is 0 and Q is also 0. So let us come and analyze this. Q is 0. Okay, so we've seen Q is 0, previous value of Q is 0. So here in this, from this line, 0 value is coming. And we know that if any input is 0 in AND gate, okay, the output will be 0. So here 0 is coming. We can verify also. K is 0. and clock pulse is 1. So 0, 0, 1 gives us 0. Okay, so this is one input is 0. And the other input is q prime. This line is coming q prime. So if q is 0, at that instant, q prime will be 1. Okay, so from this line we are getting 1. So one input is 0, the other one is 1. And we know that in a NOR gate, if 0 and 1 are the inputs, the output will be, I will show you again. So 0 and 1 will be 0. Okay, I'm showing you the NOR gate here again. Okay, and this pattern. So 0 and 1, 0. So coming back here, we find the value to be 0. Okay, so our first value is 0. So that is what we get when qt is 0, j is 0, k is 0. Alright. Now let's consider the next row. Okay, so here j and k are still 0, but q previous we are taking it to be 1. So this I have written 1 here. Okay, so q previous is 1. So that one comes here. Okay, so here we have k is still 0. Okay, so 1, 0 and 1. So because of this 0, it will be, because 1, 0 makes the output 0. So here see I have written 0 here. The first line is 0. And because the q previous is 1, q prime will be 0. So this time both the inputs are 0. Okay, and we know very well, I'll show you also, that if both the inputs are 0, the output will be equal to 1. So applying that logic here, two inputs are 0, output will be 1. And that is what we write here. Okay, so previously it is 0 and 1. And so if we see carefully, we find that my qt plus 1 is equal to my qt. Whatever was the previous value of qt, we will get qt plus 1 also to be equal to that. Okay, so it's 0, we are getting 0. And if it is 1, we are getting 1. So that means it is giving you the previous state. Very important, previous state. Now let us see the next row. Okay, so here it says 0, 0, 1. Okay, so j is 0, k is 1. And we'll first assume qt to be, q previous to be 0. So I'm writing a 0 here. So in this side we have 0 and k is 1. Okay, k is 1. So I'm writing 1. Cp is always 1. But because 1, 0 is there, the output will be 0. So the first line we got 0. Okay, so here we are assuming q to be 0. So obviously q complement will be 1. So this time here it is 0 and 1. And we all know very well that in a NOR gate, if we have 0 and 1, what is the output? It is equal to 0. So hence we are getting our qt plus 1 is equal to 0. So I am writing here equal to 0. Next is this value. Okay, so here we are assuming q previous to be 1. So quickly I'll write q previous is 1. I've written here 1. So here it is 1. K is also 1 and Cp. So all 1. So if all are 1, then we get 1. So here we are getting 1. We had assumed q previous to be 1. So at that time q prime will be 0. So from this line we are getting 0. So the inputs are 1 and 0. And we know again 1 and 0 means what? 1 and 0 means output is 0. So this time we are getting the output as 0. So I've written 0 here. Okay. So we are writing here 0. Okay. So what do we notice here is that whatever is the value or the previous value of q, okay, be it 0 or 1, with this combination we get the value, the q new as 0. The new q is always equal to 0. So in that case, it is equal to the reset state. So that is why I have written here reset state. Now we'll go to the next row. Okay. So next row has this combination. J is 1, k is 0, and we'll assume to be 0. Now here what will we do is that because j is 1, so we'll take that side where 1 is there. Okay, so we'll focus here because j this time is equal to 1. So what happens here is that because here q is 0, so q prime will be 1. So I have written 1 here. So, okay, so this side is coming 1. J we know is already 1. Cp is always 1. So because we are getting 1, 1, 1, output is 1. And because q prime is 1, q will be 0. That is what here. Q is 0. Okay, so 0 and 1 will give us again what? It will give us 0. Okay, so 0 is our q prime. So if 0 is q prime, what happens? q will become equal to 1 because q prime is 0. So that is what we have written here, 1. Okay, so we get 1 value. Okay, so now next value is when q previous is 1. So we will again focus on this lower side only. So when my q previous is 1, q prime will be 0. Okay, because q is 1. So this 0 will come here. So this time here it is 0, j is 1 and cp is 1. And if one value is 0, it will give 0. And because my q prime is 0, this q that is coming here will be 1. Reverse of that. And 1 and 0 we know from the NOR gate. Okay, 0. So here we are getting that as 0. And 0 is the output, that is q prime here. And because q prime is 0, q will be equal to 1. So exactly that we are going to jot it down here. Okay. Now again, after solving these two rows, we find that whenever the combination is 1 and 0 for j and k, no matter what is the previous value, be it 0 or be it 1, we get our q new qt plus 1 is equal to 1. And because it is becoming 1, we call it the sad state. Okay. So now we are left with the last two combinations. Okay, so here my q previous is 0 and both j and k are 1. So we can pick up any one side. Okay, so we'll pick up again the same side, j only. Alright, so here what happens? Q is 0. So we are taking q prime as 1. So I have written here 1. Can you see that? 1 I have written. This 1 is coming here. Okay, j is 1. So 1, 1, 1 gives us 1. Now because q prime is 1, q is 0, reverse. So from this side I am getting 0. So one input is 0, the other one is 1. And from the NOR gate we know it is equal to 0. So we are getting the output of that gate is 0. But that is q prime. So if q prime is 0, q will be equal to 1. So that is what we write here. Okay, 0, 1, 1 will give us 1. So now we are left with the last row. Okay, all ones. Previous value is 1. So here again we will pick up the top section. Why we are taking the top part is that because here we are getting 1. So this side we are getting all ones. Okay, this is also 1, this one, this one. Earlier we had taken this side because that was giving us all ones here. Alright, so now we'll put the value of q1 here. Okay, so q is 1. It's coming this side. Q is 1. K already is 1. CP we know is 1. Okay, so because all ones, we are getting 1 here. So we have written 1 here. Okay, so Q is 1. That means Q prime will be 0. So I'm in this particular input, I'm writing 0. So 1 and 0. Whenever we put 1 and 0, we get 0. Okay, so here I'm writing here 0. Alright. So because I'm getting 0 there, you have to write here 0. So it depends. Okay, we have to know which part to choose from. Okay, so we are choosing it here because we are putting all ones here. Earlier, all ones here. So preferably the ones giving the side that is giving us the combination of all ones. Okay, so putting all that, we get Q is equal to 0. Okay, 0. So what pattern do we observe here? That just like we had seen some similarity in these boxes, here also if we see that for the combination 1 and 1 for j and k, okay, the output qt plus 1 is the complement. Now this time it's not same, it's the complement. Okay, that means if qt is 0, my qt1 t plus 1 is the complement. Q new is the complement of q old. Okay, so if this is 0, I'm getting here 1. And if this is 1, q previous is 1, q new is 0. And because it is changing state, we call it what state? Not reset or set, we call it the toggle state. That means changing the value. Okay, and if you remember, this was the problem, this was the area. Okay, this was a combination that gave us problem in our RS flip-flop. Okay, whenever RNS was 1, 1, that was the case when we got that invalid or indeterminate state. So that problem is solved here. Okay, in GK flip-flop, that problem is solved and we get these values, which are also called toggle state. That's why I've written here, very important, solves the problem of indeterminate invalid state. Okay, so I hope it is clear. Okay, so if you do write these values like this, if you follow this kind of sorting, or let's say pairing of common values, Then it will be easier for you to remember. Now time to draw the Karnaugh map for JK flip-flop. Okay. So like we had done in our previous RS clock flip-flop, here also we'll do the same. Okay, this is our truth table. Okay, these are the combination. We have QT, J and K. With this, with the combination of these three inputs, we'll get the value of QT plus 1. Alright, so we will pick up those rows where the value is equal to 1. Okay, the way we have done earlier. So here we have 1, 2, 3, 4. 4 values. Okay, so we'll pick up the combination. So here we have drawn. Okay, this is for Q and this is your J and K. Okay, forgot to write that. So J and K. So the first combination is 1, 0, 0. So we pick 1, 0, 0. So this is my first one. Then the next one is 0, 1, 0, 0, 1, 0. This one, the 1. This one is coming from there. And then the third one is 1, 1, 0. So where is my 1? 1, 1, 0. This one here. Okay. And the last one is this, which is 0, 1, 1. So here it is, the first row, 0, 1, 1. So we get all the 4 ones here. Okay, in the Karnaugh map. And we know that we have to now map it. Put the common terms. So we are doing 2 pairing, the first 2. Okay, here. So that is shown by the dotted line. And the next pairing is this. This one and this one. Okay, now you all know the procedure. Alright, how we have to translate that. So we'll first see the first pair. Okay, and here we see what are the variables that are remaining constant. So if you look here, it belongs to the same row, which is your Q prime row. So the Q prime is not changing. So we write Q prime. Okay, and the first value, this one, first value from here, 1 and 1, same. That is also not changing. And that refers to J. So we write here Q prime J. Okay, so that is the first term. Next term is from this pair. If you look carefully, it belongs to the second row. Okay, and that is our Q. So we write Q. And the next value which is not changing is the last 0, which is our K prime. So this gives us our equation for QT plus 1, which is equal to Q prime J plus QK prime. Okay, so I hope you have understood. Okay, this diagram, this truth table, followed by the Karnaugh map and the equation. Very important. Okay, thank you.